So again, let's review everything we know so far. You know end behavior. End behavior, remember, is just about the arrows. So to review end behavior, which is just the arrows, it's always the same setup too, guys. So to show me, to let me know that we're talking about the left arrow, x is approaching negative infinity. As x approaches negative infinity, guys, what's happening to the y coordinates? Are they decreasing?
Increasing.
Increasing, yes. You are correct. Good job. And then on the flip side, as x approaches the right side arrow, right side infinity, of course, the value of the function is going down. Yes, I sure can. Thank you for telling me. And I would get rid of. All right, so please remember, look over here. Are these the same sign or are they opposite signs? Of course they're opposite. What is the highest exponent? 3. Is 3 odd or even? Odd exponents, opposite in behavior. Also, the graph is down on the right, which makes sense because it is a leading negative coefficient. If you forgot that, you better write that down. So remember, these are opposite because you had an odd highest exponent. It's going to be the same every single time. Also, your graph is always going to be down on the right when you have a leading negative coefficient. That explains the end of it. Now let's go talk about the middle. When you look in between the arrows, guys, you have 2 critical points. I have a critical point, a turning point right there. That is a relative minimum. Notice it looks like a right side up U. Right side up U's are minimums. Upside down U's are maximums. And they're relative. They're not absolute because the graph goes up forever and the graph goes down forever. So to talk about increasing and decreasing, it is always about the x values. So this first piece right here that I wrote in blue, I'm going to color coordinate everything. This first piece that I wrote in blue, that is a relative minimum. And I know that relative minimum has an x value that's somewhere in between something. Guys, look at your scale. What is each tick mark worth? What is each tick mark worth? It goes by 2's. Yes, good. So what integers is this in between? A -4, and what about that side? -2. So guys, write -4 and -2. Thank you for telling me. -4 and -2. So in order for us, we're going to guess and check. We're going to narrow it down, guys. The only way that we can narrow it down is to read the instructions at the top of page 20. Read the instructions at the top of page 20. It says to narrow it down by how many intervals? To the nearest what? 0.5. To the nearest 0.5. So we're going to guess and check. In increments of halves. See this is -4 line right here. That's the -2 line. And see how this is just floating in between? We have no idea what it is, but we're about to find out. We're about to figure it out. So let's do -3.5. See what we get. Is that in between this range? It is. Let's look at -3.0. And let's look at -2.5. And remember, we are focusing on a minimum. So this is where Desmos comes in, and I'm totally going to trust that you guys know how to work Desmos. All right, so what I'm going to do is I'm going to plug that equation in, but every time I see the letter X, I'm going to plug in a negative 3.5. Put your negatives in parentheses. It's a leading negative, so we're going to start out with a leading negative. And then remember, we're guessing that maybe negative 3.5 might be an option for us. Put negative 3.5 in parentheses, arrow out, and raise it to the third power. Make sure you're out of exponent mode when you start your next term. Your next term is negative 4x squared. Whoops. Let me get back and put my 5 there. And then don't forget plus 2. And then I have an output right here of negative 4.125. You guys should be doing this on your calculator. Are you getting this? Everybody got that? Negative 4.25. So the value of the function right down here, we're going to write negative 4.125. Here's why I love Desmos. So that's that. Let's look what it's going to be for negative 3. Guys, just put your cursor on the 5 in the parentheses and delete it. You don't have to retype all of it. So what does negative 3 give you? Just negative 7. That's all it is. Negative 7. Let's do it one more time. Let's see what kind of value we get for negative 2.5. So I'm going to delete those 3s. I'm going to type in negative 2.5. I got negative 7.375. Did y'all get that? Negative 7.375. Yes. We're all good on this? We're going to copy this down right here. Ooh, I forgot my negative. Okay, let me get the Desmos off the screen. So here's my chart. Remember, it is a relative minimum. I know it's a relative minimum because it's a U. That's the bottom. Which one is the lowest value? Negative 4.125, negative 7, or negative 7.325? 375. Guys, grab your highlighter and highlight this. Both of those numbers are so important, but we're just focused on the X's right now. So here's what's happening. Remember, we're talking about what is in between the arrows. I know here's what's happening in between the arrows so far. I'm going to make an increasing and a decreasing chart because, guys, that's just not enough room for me. I cannot fit my writing on there. I know that this graph is falling right here. So it's negative infinity. It's going down. It's decreasing. It's falling. All the way up to that ordered pair. And we figured out the lowest value of negative 7.375 is from negative 2.5. Remember, it's all about the X's. And what happens as soon as you turn the corner? What happens? It goes up. Recopy the negative 2.5 on the increase line, because that's where it starts going up. But it doesn't go up forever. It hooks back down. Thank goodness that critical point is a lattice point. What's the ordered pair for that? 0, 2 is the ordered pair, but remember, we just want the X's. So as soon as it reaches 0, it hooks back down and it decreases. See, I wrapped up the increase and I immediately went to the decrease. Immediately. And then it decreases for how long? Forever. We land on an arrow, so that's positive infinity.